Bismillahirrahmanirrahim. We are basically going to talk about the coded data, and I have taken some questions. I'll try to do at least 4 or 5 questions about this coded data, okay, from the past papers. The first question is from June or 2, and it is paper 6, question number 4. It says, in a spot check of the speeds, x kilometer per hour of 30 cars, okay, so we have n equal to 30. The data was summarized by sigma x minus 110. So we're given sigma x minus 110, that is equal to minus 47.2. And then you're given sigma x minus 110 whole square, that is 5,460, and is asking for the mean and the standard deviation of these speeds. Is asking for the mean and the standard deviations. Okay, let me write a small x with this. Achha, when you look at this sigma x minus 110, so you must take this as the sigma x minus 110 is basically sigma d over here, because we are going to use the relation here that d is going to be x minus 110. That means we have taken out 110 from each of those speeds, so that we have a, like, smaller values to be able to calculate these means and the standard deviations more easily. Okay, so now we have here the sigma d is going to be, sigma d is minus 47.2. From this, I can calculate the mean of this coded data. Please use your calculator. Tell me quickly what is minus 47.2 over this 30. Hmm?
Sir, minus 1.57.
This is minus 1.57. Now, if you look at this, the way we have coded this, so if you want to find out the relation between their means, so this is going to be like this. Okay, the difference in the means is same as the difference in the values. Let me make you recall by giving you a small example again. Like, suppose if you have let's say 12, 13 and 14, and you take out 10 from all of these values, you will have 2, 3 and 4. The mean for these three values is going to be 3. Therefore the mean of these three values is going to be 13. Okay, so you see that there is a difference of 10 between all these values. This is your x and this is your d, which is going to be, in this case, x minus 10. Okay, so you find the mean of this coded data and then you add 10 into it, you get the original mean. So similarly, this is the mean of the coded data. And if you want to find the actual mean, so you can say, okay, this mean is going to be the mean of the coded data plus 110. So this way, the mean is going to be um, minus 1.57 plus 110. So how much is this? That is 108.43 kilometers. Please use your calculators quickly, yaar. Kilometer per hour, है ना? So this is the mean. We have the mean over here. ठीक है? Are you using your calculator, बच्चों? Hmm?
Ji, sir.
Acha. Okay. And then we have to find, let me cover all of this because I don't need this now. I just made you recall through this small example. Acha. Uh, so we have this relationship between their means. The relationship between their standard deviations is that if you have coded your data, then the coded data and the original data, they have the same standard deviations. Okay, so mean is going to be this, and now if you want to find the standard deviation, so we'll be finding the standard deviation of this coded data. So this sigma x minus 110 whole square is going to be my sigma d square, because when I have to find the standard deviation, I'll be using the formula that this is going to be the square root of, let me put a small d here, that is going to be sigma d square over n and minus the square of the mean of this. Okay, so that is, now please get your calculators ready. That is 5,460 divided by 30 minus this. I'm not putting that minus here because, because of the square, this will become positive. So
Sir,
you'll,
13.4.
okay, so this is the 13.4, and I can put that equal to the standard deviation, the actual standard deviation. So this one is the mean, okay, here, and here is the standard deviation. Okay? So now let's look at the second part. On another day, the mean speed of the cars on the motorway was found to be 107.6 kilometer per hour, and the standard deviation was 13.8. Assuming these speeds allow a normal distribution. Okay, so this is a question on the normal distribution, so I'll not be doing this right now. Okay, I'll be moving on to the next question now. I'm going to clear this. I'll move on to the next question. I'll close this window, and here is the next question. And this question is from March 19. Okay, March 19. Okay, now this is the February, March 19th, variant 6.2, question number 2. It says for 40 values of, now I'll be noting it down. The first thing that I have n equal to 40. It is given that sigma x minus c. So sigma x minus c whole square is 3099.2. And I will be noting it down as my sigma d square. Okay. This time we have the coding like this, x minus c, that is equal to d. Okay? Acha, the standard deviation of these values of x is 3.2 is giving us the original standard deviation, that is going to be 3.2. Acha, we know that the original standard deviation or the standard deviation of the coded data, they are same. They are same. So now it says find the value of sigma x minus c. In a way is asking for this sigma d, that what is this sigma d. Okay, now I think we can use this standard deviation over here. Can I say that the square root of sigma d square over n minus this sigma d over n whole square, that is equal to 3.2 क्यों बच्चों, है ना? So we
Ji,
have
sir.
sigma,
Yes, sir.
yeah, we have sigma d square with us, which is 3099.2. We have the number, which is 40. We have to find this sigma d. We have the number, and I'm going to put the square on it. Okay. So here is a square on it. And then I'm going to write this is equal to 3.2 square. Now there is some algebraic manipulation. This is going to be 3099.2 over 40 minus 3.2 square. That is going to be sigma d square over 40 square would be multiplied by this here. Okay. And then you take its square root and tell me what is this sigma d. Yes, tell me quickly. Do all this calculation.
Sir, 328.
This is 328. So you have already calculated that. Good. So that is 328. Okay. You see, I'm not using calculator at this step. I just wrote all of this, and then in one step, we can find this value. I hope this calculation of yours is correct. Okay. Now it says, given that C is 50, find the mean of these values of X. Acha, look at this. You people have already got sigma D, which is 328. If you divide this sigma D by N, you will get the mean of the D. Right? So can I say the mean of this D is going to be 328 divided by 40? Right? So how much is this? Tell me quickly. 328 divided by 40?
Sir, 8.2.
8.2. Now we have that D equal to X minus C, and he's giving this C as 50. Okay, na? So this implies that your mean of this coded data is going to be the actual mean minus 50. So if you want to find the actual mean, that would be the coded data's mean plus 50. So you add 50 into this. So that will be the mean. That is going to be 58.2. That is your mean over here. Okay, that is how you find the mean. And this question ends here. ठीक है बच्चों? Okay. So let's move to another question now. I'm going to close this. Okay. Now the next question that I have here, this is from uh, February, March 18, and this is the variant 62 again. This is basically the Indian paper because in India, they have exams in February and March. Okay, give it a try and then I'll do this for you. Okay, I hope you people have tried this. You have your pen and pencil with you, your copy with you. Okay, he says a summary of n values of x gave the following information. Sigma x minus 20 is equal to 136. So I will be noting it down that sigma d is equal to 136. As I know here that x minus 20, that is going to be my d. And later on, the mean of this x minus 20 would be the mean of this coded data, and we can determine it through this relation here. If we have to find the actual mean here, okay? And then their standard deviations would be same. The coded data and this original data, they will have the same standard deviations. Acha. Now we have sigma d equal to 136 and we have sigma d square that is equal to 2888, okay? And it says find the value of n. So if we are given that the original mean is this, we're given that the original mean is 24.25. Let's find this coded mean here. That is going to be 136 over n. N is not given to us. This is this, okay? Now, through this relation over here, we know that the original mean, which is 24.25 minus 20, that is equal to the coded mean, that is 136 over n. So this is 4.25 equal to 136 over n. So your n is going to be 136 over 4.25. Use your calculator and tell me what is this n. 136 over 4.25.
Sir, 32.
Sir, 32.
Okay, this is 32. So is that clear? How did we find this n over here? Okay. Okay, in the second part, we have to find the sigma x square. Now, this sigma x square is actually a part of the formula of the standard deviation. Okay. Now, we have all those required values here to determine the standard deviation. Okay, na? Say, na, of the coded data. You have sigma d square, you have sigma d. Okay, na? So let me cover this area so that we can do that working for sigma x square. We're going to find the sigma x square now. Okay. Can I say, bacho, can I start by saying, KG, the standard deviation of original data is same as the standard deviation of the coded data, है ना? And this would be the square root of sigma x square over n minus its mean square, and that is going to be equal to sigma d square over n minus its mean square, है ना? And we can cancel out the square root with the square root by squaring both the sides. Now we have here sigma x square. What was this n? That was 32?
Ji, sir.
Yeah, that is 32. And then minus 24.25 square. And that is equal to sigma d square. We have 2888 over this 32. And I think its mean was 4.25.
Ji, sir.
4.25 square. Okay. So guys, you use your calculators and you must be able to find this. Like this would become sigma x square equal to 32 into this 2,888 over 32 minus 4.25 square. है ना? That's it. 32 into
Sir,
this.
plus 24.25 square b होगा sir.
Plus, yes. I'm missing that. Plus 24.25 square. So this is how you will be getting your sigma x square. Can you find that
Sir,
for us?
21130.
Okay, this is 21130. Acha, I have a bit doubt here. 211. Oh, yes, this is because this had to be much bigger than this value. I thought this is just 2113. So this has to be a lot bigger than this. Okay, na? So anyhow, so this is how you had to find this sigma x square from here. Okay? So shall I move to the next question then? Hmm? Okay, this question is from March 17. Okay? It is a very first question over here. It says the 12 values of x are shown, and it says find the mean and standard deviation of all of this x minus. This is how he has coded it. Basically, your d is going to be x minus 1760. Okay? Acha. So you have to take out 1760 from all these values. Okay? One way is that you take out 1760 from all of these one by one, and that will be your D. Then the smarter way of doing is that you, since you people have calculators with you, you find all these values, okay, and subtract 1760 how many times? 12 times from that. Okay, lekin since you have to find the standard deviation as well, so I think you find this because it's giving you 4 marks. So let's write 1761.6 minus 1760, that will be 1.6. Okay, and similarly 1758, so this is going to be minus 1.5, Hannah. So this way you find all these values. Having got these values, now you use your calculator to find sigma d. Okay, to find sigma d, that will, through this you people will get the mean. Okay, he's asking for the mean and standard deviation of this d. This is basically your d over here. Okay, acha, so please use your calculators and tell me what is your sigma d square as well. Okay, use your calculator for this, and then we shall find the mean through this sigma. Please use your calculators. I'm waiting for you people. And then this standard deviation would be the square root of sigma d squared over n minus this d squared.
Sir, sigma d is 11.3.
Okay, and give me quickly sigma d squared. So through the calculator, we got sigma d is 11.3, sigma d squared is 41.3. So now, can you tell me what is this mean 11.3 over 12?
Sir, 0.94.
Zero. This should be correct to 3 significant figures, by the way. Is that exactly 0.94? Hmm?
Sir, 0.9417.
0.942.
Okay, 0.942. That is your mean. Now, while finding this standard deviation, we'll be trying to use the exact values over here, okay? So this is 41.3 divided by 12, and I'll use this as it is 11.3 over 12 whole square. Now, please tell me how much is this?
Sir, 1.9, 1.59. 1.6.
1.59. Okay. If you have used your calculator correctly, then this should be the standard deviation of this coded data. So we have got the mean and the standard deviation of this coded data over here. And then it says, hence find the mean and the standard deviation of x. So the mean of this x would be, you will put that 1760 back into this 0.942 So that would be 1760.942. So writing in the way he has written it. So let's keep this correct to one decimal place. So the mean is going to be 1760.9 and the standard deviation is going to be the same, that is 1.59. Okay, so we have done this quickly because we have used the coded data. Okay, so guys, I think
ठीक है सर.
we have had enough practice from the past papers. Now this is up to you. You people go into the past papers and try from there. If you have any problem, let me know. Thank you very much. Allah Hafiz.